This is another training type problem. We're not yet at the point where you can graph these things on your own, but I want to keep looking at this graphing window right here. This dotted line that I've drawn around one complete cycle of this sine or cosine function, whichever it is. This one's actually a sine function. Okay, and I have the equation up here, and we're going to fill in where those key points land for this function, and then we're going to talk about some of those key features like amplitude, midline, period, and so on. So some of this, you can just do this from the graph. You can look at the point A, for example, and say, okay, x is 0, y is -2. And that's probably the quickest way to do this, just so you get practice looking at these graphs where the x coordinates are in pi values. Let's see. For this next one, B is at x equals pi, y equals -6, C equals x equals 2 pi, y equals -2, and so on. Now, when it comes to filling in the bottom portion, right, all these key features, you can do that either by looking at the graph or by looking at the equation. And I would suggest both. Okay, we're still learning how these things work. We've seen examples where you just pull it from the equation. Okay, right? You might remember that A, the amplitude, is the number in front of the sine function. It's the absolute value of that number. So we would say A equals 4 in this case. But how would I pull that out of the graph? Well, take a look. We've got our midline here. I'm going to draw the midline right there. You can see that's in the middle of the function. That's why it's called the midline. So, maybe let's just fill out the midline while we're at it. Y equals -2. There's the equation. And you could have seen that right from here. But in the graph, the midline runs down the middle of that sinusoid. And the height that you have to go to reach the peak, or in the other direction, the distance you have to go to reach the trough, that's the amplitude, which is 4 in either direction, and we can put that right here. Now, in terms of the b value, it's very difficult to get the b value from just looking at a graph. You have to do a little bit of equation work with that. So what you're going to be looking for is the period. Once we know the period, we'll get to the b value. So first, I really want to talk about the period of this function, and that's not obvious from the equation. For that, you might want to just look at the graph, actually. You see this one goes from 0 all the way over to 4 pi. So the period is 4 pi. And now we can use that to figure out the b value. So the period equals, remember that's 2 pi over b, and that's 4 pi. So solve it for b. That gives us 2 pi equals 4 pi times b. Divide each side by 4 pi, and you get this, 2 pi over 4 pi on the left equals b. Now 2 pi over 4 pi is just 1/2. So this is how you would graphically figure out what b is without looking at the equation. But if you were just looking at the equation, well, b is obvious, right? b is just the number that's multiplied by x. So if you're looking at an equation, b is easy. If you're looking at a graph, period is easy. And each one of those can lead you to the other one. Now, this last part, phase shift, we haven't really talked about phase shift yet. Okay, we haven't gotten into that. And you can find this either from the equation form or from the graph form. For now, I'll just point out that the phase shift is whatever position your graph window starts at. So you see this square, this dotted square I have around the function? It starts at y equals 0. So I would say my phase shift equals 0. And we'll get into some examples of non-zero phase shifts in a little bit. That'll be later.